I've already been told that this is impossible, but the reality is that it's true. Okay, so regressions, this is something that is the bane of most of our lives, is having to run regressions. They take far too long, they take too much resource, and of course we have to debug the failures once we have run them. So over the last 13 years at Infineon, I have developed quite a number of different regression scripts and tools, and and so I've got a bit of experience, I guess. So at the end of last year, I'm working on a CPU verification project, and at the end of last year, we took a step back and looked at why our regressions would appear to be slow, and we looked at some of the fundamental things that were going wrong with our regressions. So that's what my presentation is going to talk about, the key aspects that we looked at and improved on to give us exactly what the headline says there. 10 times faster regressions, full stop. Is this going to work? Nope. Nope. Is this on? Perfect. Thank you. There we go. I'll use that instead. Okay, so first, this is a CPU verification project. We have lots of test cases which we run in the regression. A test case contains some assembler files, some test bench control files, and some metadata. These test cases are organized into test suites, and then they are run as regressions. So, looking through this, the test library, we have about 45,000 test cases, which can be run as various different test suites on different CPUs, or versions of the CPU. This test library is a version-controlled directory structure, and for each test there's a number of files in a given directory. Each day we add tests to this. We generate new tests, we write new tests, and these are added to the library. So at the end of each day we have to label this test library so that we have some snapshot in time, so we can go back and repeat the results. So the time scale along the bottom is trying to show where the time is used in. So for a 20,000 test regression that we might run, it was taking 3 hours to actually label the test library, which is quite a long time. But this is mainly because we were using ClearCase as our versioning tool. Okay, so when we go to run a regression, we have to create a run. We used to create a run area, and that was 20,000 directories built in some network filer somewhere inside on the cluster. And that copy used to take almost an hour and create those directories, which to me seems like a long time. Then from that run area where the system worked, we had to then use a find from that run area to find our test list. From that test list we could, and that find was taking half an hour or so to go through that whole directory structure and find it. And then we used to, then from that test list, we can submit each job to LSF. And we weren't necessarily using LSF, which is our load sharing platform, if you don't know what LSF is. And we were submitting one job at a time to the cluster, but they could be running in parallel. So the submission time, was almost 5 hours to submit the 20,000 tests onto the cluster. And then each test was run in turn inside that test run area. And the limitation we had due to the system was that we could only run 300 jobs in parallel. And then eventually, everything was, when it eventually ran, we could then generate a report and get at the end. So, as you can see, if you add all these times along the bottom, you end up with 10 hours to run a 20,000 test regression. So, we sat back and looked at this, and the areas that we found for improvement were the test library. So, I'll go into more details. We looked at the fact we were using network storage, which we weren't using LSF in the best possible way. Okay, so test library. So the issues, I've already said, clear case labeling was very slow. It took 3 hours. And we also broke clear case by exceeding the number of elements that you could store in a Bob. And we've had an ongoing case with the provider of clear case to fix it for the last 2 years, and they still haven't done it yet. So I don't think we're going to get a fix, hence the reason we've gone down a different route. So we looked at a number of different solutions for storing tests. We looked at other version control tools. We looked at Git for Respond, for instance, but still it used for network storage, and ended up with multiple copies of various things in different places, which was another limitation. So our solution that we've come up with is to create an SQL database, store all our test cases. For all the hardware engineers at Vinian, this seemed quite a fundamental change in thinking, and there was some resistance initially. Questions like, well, where are my test files? If they're in a database, I can't find them, I can't ls them, I can't open them up in an editor, and all this sort of thing. There was, well, which directory? Same question. And also, but there's no version control inside a database. How on earth are you going to keep track on which version of a test we were using? Well, as you see, our solution came up, fixed all these problems. So first we developed a interface script for the users to use. So this allowed them to pull tests out of the database, put tests in, edit them, and do various things, operations on the test. We can, okay, so tests have metadata, which once in a database is a lot easier to search. We can, and then the test list generation, that was one of the slow steps. In our old flow, it was taking about an hour and a half to eventually get to the test list. And that can now be done instantly. And also the fact that we were storing test cases files, the actual files in the database, was another step beyond what people were comfortable with at the time. And we've also, the way we've implemented the schema for the database allows us to instantly label the entire test suite, and it also allows us to check out and check in test cases. Yeah, okay, so that was our test database. The second aspect was the use of network storage. So, as we saw, it was slow to create large directory trees. It was taking an hour for 20,000 directories, which seemed like a long time. It was slow to write to once you're executing a test from that network directory. And I guess the trend has always been that to make things go faster, you throw more CPUs at this problem, and if you keep going, you'll end up finding everything writes back to some central place. But the problem with that is we found that once we hit 300 jobs running in parallel, the speed of execution fell off a cliff, and you might as well have run 10 jobs in parallel. So our 10 hours would go up to 24 hours or even more. So it was more than 300 jobs started running. And then the other issue with network storage is you've got this big directory tree that you've created, and then when you start the next day, you clean it up and throw it all away. Okay, so where did I go? So one of our IT people at the office, it's very helpful, came up and suggested that we started using local disk. There's a lot of disk on every machine that never gets used, and so we decided we'd give this a go. So this is what we did. Rather than use that network storage, that we load a test directly onto the machine it's executed on, run it there, and then save the result into a database, and we remove the directory and throw away the content of the directory after it's run. So what this does is it typically saves us 20 seconds per test, so which on a test, an average test length of 100 seconds, is 20% of every test we've saved 20% on execution time purely by not using the network disk. And the best bit is we've actually removed that false ceiling of 300 jobs, and we can actually utilize 700, 800 or 800 CPUs that we might have on site. Okay. So the third point is we weren't using LSF very efficiently. So we had a submit time of 1 second per test, and which meant you could never quite achieve the numbers of parallel tests you might like. So our solution, well, the same IT person, he suggested, he kept telling us we should be using JobArrays. This was something that seemed to get resistance from lots of people, again, but we went with it. And we had a student who come in and taken one of my previous regression implementations and on a different project, and for his final year project had switched it to use JobArrays, and he'd sped up the regression by a lot. So this is another thing. Basically, it allows you to instantly submit all 20,000 tests instantly onto the load sharing system, and from there it can schedule your jobs much quicker onto all the execution hosts. It also allows you to do job chunking, which is something specific, I guess, but it also speeds things up. And of course, it's easier to get statistics out of LSF once you've got JobArrays, because and one thing that this IT person that keeps propping up in this talk, he'll come up to us in the morning and say, why were your regression running 23% slower last night than it did the night before? And we'll go, look and find out someone's turned on some new log file, which may be unnecessary, and slowed us all down completely. Okay, so with those 3 changes, we can look at what the new regression flow looks like. So, and the time scale along the bottom as well, which is 10x faster thing. Okay, so our test database, we have instant labeling, so there's no time taken. There's querying and getting our regression test list out of the database. Again, it's instant, so there's no time on the timescale used. Then submission to the job sharing or JobArray, that's again instant, possibly reduced 10 seconds so far. And so then once they're all in the JobArray, they're executing a lot quicker. And because we're not using network disk, they're not executing quicker. So now a job to run a test, it involves creating a directory on the local machine, grabbing the test out of the database, running that test, determining the result, and recording that in our new results database. I haven't mentioned that until now, but we're storing all our regression results in the database as well. And then from there we can, as soon as a regression has been started, the web page interface is allowed to give you an instant feedback on how your regression started, how it's progressing, and of course you can get results at a later point, which is quite a good point to a regression runner to be able to actually see your results quickly. Okay, I think that's so. The timescale on the bottom is it only takes an hour now to run all 20,000 tests rather than the 10 hours it took before. Okay, so to summarize, we used to have a coffee break regression or mini regression of 200 tests, which used to get quite a good coffee break in that 20 minutes. But it was only running 200 tests. Now we've increased that. So that's reduced in time from 20 minutes to 2 minutes. It's almost become, well, it's faster to run a mini regression now than it is to compile the design. Our midi regression has now become the new coffee break regression, and we get a much better quality check on our design and verification environment. So design and verification engineers can both use this to check the changes. And rather than taking over an hour, nearly an hour and a half, that's now down to 10 minutes. And of course, what we used to have is an overnight regression on our full regression of all our tests, taking 10 hours is now down to less than an hour. And so we can turn around multiple releases and do a full regression run multiple times each day without waiting until the next day to find out the result. And my point here is, I guess we've done it all with free tools, without any new hardware or the need for any new EDA software.
Yeah, thank you very much, Mark.
There you go.
I assume you've had to go from cappuccinos to espressos.
Yeah.
Any questions from the audience? JL? Joe, you always sit at the back and ask questions.
Hi there, JL Gray from Cadence.
Hi.
So you said that you made a database to keep your tests, and then you didn't have revision control of your tests.
No, so, I said we do have version control within the database.
So you made a database that can revision control your tests.
Yeah.
So why didn't you just, I'm trying to understand the benefits of the clear case, which you seemed keen to keep. Why didn't you just switch to a version control system that didn't have the restriction on the labeling?
Because it's still storing, access to a database is much faster than most version control systems.
Even a version, okay,
That's what we found. It's
okay.
sort of a fundamental change in thought,
but some of them are actually databases, so that's
yeah,
what I'm just,
I agree, but
we
we have a lightweight front end on that database, so we don't spend lots of time handling the data.
So you found, okay, so you basically found it useful to create your own version control system.
Which was, it really isn't complicated version control within that data. So our database works, continuously moves forwards. We don't go back in time and branch off and start doing various other things.
Okay.
So everything is always latest version of all tests work for all the different processes we're working on.
Okay. See, I thought it was those of us from the U.S. who were the ones that like to do our own solutions.
Any more questions? I'd like to ask one question. It's quite interesting. When you bring the time down for your regressions, it must enable lots of new things. Like, so now your turnaround time is 50 minutes. So rather than do a regression at the end of each day, you can do regressions.
Yep.
Do you go for, does that enable continuous integration?
So in theory, it now allows designers even to run a full regression on their RTL changes within an hour. It, yeah, like I said, it allows us to do multiple releases each day and verify them, or even verify multiple processes at the same time.
Okay.
Which is something Tim might be talking about in a minute.
Does that mean designers checking their bugs?
We've only just rolled this out in the last few months, but we have seen a lot less issues with code coming from.
Yeah, because I think the interesting thing is the consequences in the verification flow, not necessarily just the connect.
It's
okay, thank you.